No, you don't have to. In that, I will succeed. I don't think it's horrible.
All right, while we're waiting, we take the roll and start answering some questions. Everybody have a good Halloween?
Yep.
Right before I walked in here, I got a call from school that my daughter has a tummy ache. But hang in there for 2 hours.
Right.
I'm sure it's from candy, or I hope. Just 1 second.
Oh, I was like, is that one?
No, they're each worth 4 points. If I write something else, that means I'm losing some credit. So in other words, I'm losing points for that. Those are each worth 4. And guys, I put all your test grades, the last test and this one, into Math Lab, just so you can see what all your scores are. But it is not a true reflection of your grade in the class. So don't take the grade book in Math Lab and think it's your grade, okay? That's simply just so you know what you have for test scores. Okay, so I will field questions. Melody's not here, Carolyn's not here. Okay, let me have it. There is one particular question I think everybody or almost everybody missed. No. Because it's something you should know. It's number 19 on version 1, and it's probably the same number on version 2. Yes, 19 on both tests. They're just going to look a little different. I'll do version 1, but the same rule applies for version 2. Okay, when we divide a monomial by a trinomial, we're taking the 3y out of each term. So this becomes 2y squared. 2y squared minus 3y plus 1. This plus 1 is what everybody forgot. The 3y still goes in this term. It didn't just cancel. I know you're thinking of when you have 3y over 3y, it canceling, but when you have addition subtraction, it does cancel to become 1, but the 1 is still there.
If you had had a negative 3y on the bottom, would it have canceled out?
No.
No.
It'd be a minus 1 if there was a negative 3y. Because you're really just doing this.
Okay.
And 3y over 3y is 1. So for whatever reason, just about everybody missed that.
So that's all 3 points?
4.
All the questions are worth 4 points. Unless I wrote something different, that means I gave you some credit.
We were just testing on that one.
Okay.
That's why we all missed it.
You did? Yeah, not everybody missed it, but a lot. What other ones would you guys like to see done?
Can you do number 23?
On which version do you have?
On that version 1.
Version 1, number 23. Okay. So the current national debt is 15, I think that's $1 trillion. Yeah. So the first thing we need to do is write that in scientific notation. So that should be 1.55 times 10 to the 13th. The population is approximately 310 million. If the debt was divided by population, it even tells you to divide. If the debt was divided by population, what would each share be? So now we have to write the 31 million in scientific notation. That's 3.1 times 10 to the 8th. So that's our problem. We write it in scientific notation and solve. 1.55 divided by 3.1 is 0.5. 13 minus 8 makes that 10 to the 5th. But our answer has to be in scientific notation, so we're going to move this decimal once to the right and makes this a 4. Okay, and then to have it in the other form, decimal form, would mean 50,000. So if each person could just cough up $50,000, we wouldn't have debt. Cough, cough, cough.
24.
Number 24, A. Okay, perimeter of a rectangle. I'll tell you what most of you did wrong on this one. They want the perimeter. Perimeter is twice the length plus twice the width. A lot of you did 2L times 2W. Perimeter, you're adding. So this should have been twice the length plus twice the width. Distribute and combine like terms, and that should be your answer. Okay. Did you multiply? Yeah. You weren't the only one. A lot of people did. But perimeter, you're just adding the sides. Area, you're multiplying. Yes, ma'am. 15 version 1. Okay, this is 2AB times 9A squared minus 5AB plus B. So what you're doing is you're distributing this monomial to the trinomial. So we're going to take 2AB to each term. Okay? So 2AB times 9A squared is 18A cubed B. 2AB times this one is a negative 10A squared B squared. And the final one would be plus 2AB squared. Does that help? Other questions?
Version 2, number 14.
Version 214, okay. Version 2, number 14 says 6x minus 2 plus x squared minus 8x minus 9. Now you can add this just going straight across, or you could write them in columns. If I wrote it in a column, you would line it up in descending order. So it would look like this. We add these and we get a negative 11. Add these and you get a negative 2x, and the x squared's by itself, so it just comes down. Now if you didn't do columns, and you go straight across, you're just combining like terms. There's no other x squared, so it's still there. 6x minus 8x, and negative 2 and negative 9.
Isn't 6x times 2x squared 6x to the third?
You don't multiply, you're adding.
That's what I did wrong.
Yeah.
Okay.
You probably distributed.
I did. That's what I did.
Yeah, it's addition. It's actually one of those problems that's easier than it looks, so sometimes you make it too hard. Yes?
It's not about the test. Our grade on D12, is that an accurate grade or no?
No, and I just said that. No, it's okay, I think it's before you came in. I put all the test grades in there just so you have a record of what you made, but it is not an accurate reflection of your average. It's a good idea because it factors in homework and tests, but it doesn't have the quizzes.
What about if you do the average of the test scores? Is that a better?
That would be a real good indication of where you're at. Depending on how you did in quiz and homework, you can either bump it up or take it down a few things. But to just get a rough average, I would take the average of the test. Anything else? Okay guys, let me come around and collect them. Yeah, that was a rough one, unfortunately. Okay, we get to start chapter 5 today. And we are going to cover 5.1 through 5.3. Okay, 5.1 is going to be about factoring a monomial from a polynomial. So we're basically going backwards from what we just did. Just like you have multiplication, division, subtraction, addition, factoring is the reverse of multiplying polynomials. Okay? So what we learned last time was how to multiply a monomial times a binomial. And we saw that it was distributing the 3x, and we got 6x squared plus 15x, right? Now they're going to give us 6x squared plus 15x, and we have to turn it back into this.
Isn't it 6x?
Yes, it is. Me too. Okay, so now we're going to turn it back the other way by taking out the greatest common factor of both terms. And we're going to go into this in detail. But when you take out the greatest common factor of these two, it would be 3x, and you end up with the 2x squared plus 5. Okay, so we're just going the backwards way. Before we talk about greatest common factor, we're going to talk about prime numbers and prime factorization. That's something you covered back in 045. And we're just going to touch on it again so we understand how to find the greatest common factor. So what is a prime number again?
Number that cannot be taken out.
It's two factors that only have one in itself. There's no other factors, not including one. So a number greater than 1 that has factors only factors of 1 and itself. For example, 2. 2 doesn't have any other factors except 1 and 2. 3. Does 4 have factors other than 4 and itself? Or 1 and 4? Yes. So it's not prime, because you can say 2 and 2. 5 is a prime number, 7 is a prime number. 8 and 9 are not, 10 is not, 11 is, and so on. Okay, so prime numbers only have factors of 1 and itself. The converse to that is a composite number. And basically, it's just greater than 1 and not prime. So whatever's not prime is composite. So it would be 4, 6, 8, 9, and so on. And you noticed in both of these it's greater than 1. So 1 is neither prime nor composite. It's just 1. Okay, so prime and composite numbers are everything greater than 1.
Did you guys have one?
Nope. Just 1. Okay, so let's review prime factorization. This is the tree. I think you're going to remember it when I do it. Prime factorization just says I'm going to break up a number into its prime factors, prime components. So what are 2 factors of 48? 6 and 8, 2 and 24, it doesn't matter what you pick. You're going to end up the same place. 2 factors of 6. 2 and 3. Are those prime? Yes, so you can circle them when you get down to a prime number. What are some factors of 8? 2 and 4. 2 and 4. 2 is prime, but 4 is not, so I have to keep going. Once you've gone as far as you can, you've reached all the prime numbers. This is the prime factorization of 48. I have 4 2's, so I'm going to write it in my shorthand with exponents. 2 to the 4th times 3. Okay, 2 to the 4th times 3 is my prime factor of 48. If you were to multiply that back out, you would get 48. It would be 16 times 3.
So if you were dividing 48 by like 3 times 16, you would do the same. 3 would be the prime number, and then you take 16 and take the
Yes,
prime
and
number.
that's actually another way you can do this if you don't like the tree way. If you said 48 divided by 3, we got 16. That's prime, but now I have to do 16. And I would say, what's a prime number that goes into 16? 2. That's prime. Then I'd take 8 and say, what's a prime number that goes into 8? 2. What's a prime number that goes into 4? 2. It's the same thing.
Okay.
Just keep dividing until you end up with only a prime number. But I kind of prefer the tree way. But this is just another way to see it.
It's cleaner.
Yeah. Whichever way you prefer, it works. So the whole idea with the division way is you just keep dividing by a prime number until you end up with a prime number. Okay, let's try another one. And you'll see why we're doing this in a minute. The whole idea is to get to a greatest common factor. So let's look at 54 and take the prime factorization of it. What are 2 factors?
6 and 7. Yeah,
6 and 9. Does everybody know what I mean by a factor? 2 numbers that multiply to get 54. Okay? 6, 2 and 3, those are prime, I can circle them. 9, 3 and 3, those are prime, I can circle them. So my prime factorization is 2 times 3 cubed.
Did you circle?
No, no, it's just, this is what you need to find. So however you want to determine that, you don't have to circle. It's just a way to know you've reached the end. No. 80, let's do this one. 2 factors. 8 and 10. 2 and 4. 2 and 2. 2 and 5. They're all prime, so my factorization is 2/4 times 5. Does everybody get the idea? Okay. So what are we going to do with these? The greatest common factor is the greatest number that divides evenly into each number. That's what a greatest common factor is. So if I were to try to find the greatest common factor of 48 and 80, let's say, the GCF of 48 and 80. How I'm going to find it using prime factorization, the GCF is the greatest factor that goes into both.
Maybe 16.
It is. Okay. So let's say you didn't know it was 16, okay? And we have our prime factorization. What you're going to do is say, my prime factorization of 48 was 2 to the 4th times 3, right? My prime factorization of 80 was 2 to the 4th times 5. All you're looking for is the one they have in common, the greatest one they have in common. In this case, they both have 2 to the 4th, or 16. That is the greatest common factor of 48 and 80, because they both have 16 that go into both of them. And that's why we're using these trees. If you have big numbers, that you don't automatically know what goes into both. This is one way to find them.
So once you find that, what do you do with the other numbers?
Nothing. You're just looking for the greatest common factor. Okay? Okay. Say it's not a big number. Say we don't need to do prime factorization. We just want to know what is the GCF of 6 and 8. What would that be? What factors go into 6? You have 1 and 6, 2 and 3, right? What goes into 8? 1 and 8, 2 and 4. Is that about it? What's the greatest common factor of both? 2. So when you have smaller numbers, you don't have to do the whole factor tree. You just see what is the greatest common factor they both have. The prime factorization tree is if you're looking, like, say, at 576 and 38, or something like that. You know, you're just looking at bigger numbers and you're trying to find 2. All right, let's practice some more. Let's find the GCF of 56 and 124. Okay, I want to find the greatest common factor between these two numbers. I'm going to start by doing a factor tree for each. Okay, that's my factorization for 56. 124, I'm going to pick 2 and 62. If you don't know a number right offhand, if it ends in an even number, 2 will always go into it. So it's a good place to start. Okay? It's only if it ends in an even number. Like this one ends in an even number, so I know 2 will go into it. Do you think 31 is prime?
Mm-hmm.
Yeah, there are no other factors, so I'm done. So this one has 3 2's. I'm writing it this way this time instead of 2 cubed. And this one has 2 2's. So what is the most they have in common? 2 2's. 2 2's is equal to 4. So the GCF of these 2 is just 4. That's the highest number that will go into both of those. Does that make sense to everybody? Sure, no problem. As soon as you find your factors, then you compare the 2. And you say, what do they have in common? The most they have in common are 2 2's. 2 2's are equal to 4. times 34. So that is the largest factor that will go into both of these numbers. Okay? All right. Now let's do some practice of taking the GCF of terms. Okay, so we talked about GCF of numbers. This is GCF of 2 or more terms. What if I had this list of terms? What is the GCF of these 4 terms? Do you think?
X
cubed.
squared.
X
Oh,
cubed.
X.
Good. And the reason being 3x's, 4x's, 5x's, 6x's. The most number of x's I can take out of all of these is 3. So it's always going to be the lowest exponent because that's the most I can take out of each of those. So what would the GCF be of this listing?
Y squared.
Y squared. So the GCF is y squared because that is the most I can take out of everything. Okay, so when you're looking at variables with exponents, you're taking the lowest exponent as your GCF.
Questions?
Let's look at the GCF of a squared b 7, a 4b, and a 8b squared. Okay, what's the most a's I can take?
B squared.
2. What's the most b's? 2. So my GCF is just, no,
No,
there's only
1.
one b. A squared b is the most I can take out of each of those terms. Okay? Okay, what would be the GCF of these 3 terms? Just p cubed.
No, just Q.
Right. Why?
There's no P in the last one.
There's no p here. So the most I can take out of all of these is just 1 cube. Very good. Okay. You have to look at each one and say, what can I take out of all 3 of them? Can I take a p out of all 3? Like, I can't take a p out of here, can I? Because there is no p. So you can't take out a p, but they all have at least 1 cube. So that's the most I can take out of all of them. Good. All right, how about the GCF of now we're going to combine numbers with the variables. So first look at the numbers, the coefficient. What is the greatest common factor of 12, 18, and 28?
3B.
Well, let's start by 12. We know 6 and 2, 4 and 3. Go in there, right? Can I take a 6 out of all 3 of these? No. Can I take a 4 out of all 3 of these? No, I can't take a 4 out of 18.
So 2B.
So
your grade.
Yeah, that's okay. That's okay. Just right now we're just looking at the numbers. We're not worried about the sign.
So 2B would be your greatest common factor.
It is. So 2 is the highest number I can take out of 12, 18, and 28. Okay? Does everybody see why? No? Okay, let me back a step. Let's take this one, 12. Different combinations or factors are 1 and 12, 2 and 6, 3 and 4, right? Those are the factors of 12. I need to look at these numbers and see if they'll go into both of these. 12 will not go into these, so I know that's out. 2 will go into all of them, so that's an option. Can 6 go into all of them? No. Can 4 go into all of them? No, 4 can't go into 18. And can 3 go into all of them? 3 does not go into 28. So, by process of elimination of all the factors, the only thing that could go into all three was 2.
You can't use decimals?
Can't use decimals. No.
For example, 4 wouldn't go into 18, or wouldn't go into 18 evenly, but I'm just
Correct.
asking
4
a question.
does go into it, but not evenly. And I
Okay.
should correct, if it's a factor, it will go in evenly.
Okay. It has to
We're
go in
looking for
evenly.
greatest common factors, not just if they're divisible.
Okay.
So I should restate that.
So how can you know you were like bigger numbers like having even something?
In the tree. Yes. And that was the whole point of the tree. If it was something I couldn't eliminate these this quickly, let's say it's 524, I mean, by the time you wrote out all the factors, that took all day. So the prime factorization is the better way to go.
So basically, you're just looking for what they all have in common.
Correct. What greatest common factor?
Okay.
The highest factor they all have in common.
And then you move on to these.
Then you move on to B. So we've determined 2, right?
Yeah.
We don't care about the sign, which was a great point Brittany made. Right now, this is negative, these are positive, but I'm looking for the common factor that will go into all of them. So I don't care about the sign. How many B's can I pick out?
One.
So my GCF of these 3 is 2B. Let's look at the second one. We have a y cubed, a 9y to the 5th, and a y squared. What's my GCF of these 3?
Y squared.
Just y squared. Good. Because that is the lowest amount of y's I can take out of all of them.
So if you were going to multiply them back, you would say y squared times y equals y to the 3rd. Y squared times 9y cubed would be 9y to the 5th, and y squared times 1 equals y squared.
Which is what we'll get to when we start taking them
Right.
out and factoring. Right now, we just have to determine what this GCF is and then show you how to pull it out of a number. Good?
Well, I think I was getting lost because I didn't realize that there was another step after this. Does that make sense? That,
But sometimes
okay,
on a test, it could just ask you for the GCF.
Okay.
There's not necessarily another step after this.
okay.
We're just using this skill to move on to something else. But you still need to, it could be a question that just says, what's the GCF? Okay? Let's look for the GCF of these 2 terms. This looks a little different. What do those 2 have in common? The y minus 2. So it looks weird, but the GCF of these 2 is y minus 2. Okay, that's what those 2 terms have in common. How about the GCF is x plus 6? And this is going to be important in a little bit when we talk about factoring by grouping. You have to recognize that sometimes what they have in common is a binomial. Okay, so now using this GCF information, let's talk about how we're going to use it. How to factor out the greatest common factor, a monomial from a polynomial. Okay, they've asked us to factor 8y plus 12. The first step is to determine the GCF of the terms. What is the GCF of these 2 terms? 4. 4 is the only thing that will go evenly into both. So the next step is to write each term as a product of the GCF. So what that means is I'm going to say 4 is my greatest common factor, and I'm going to divide 4 out of each term to see what's left. If I pull a 4 out of 8y, what do I have left? 2y. If I do 12 divided by 4, what do I have left? 3. That is how you factor. So the factor to this binomial would be 4 times 2y plus 3. And you can go back and check yourself by distributing. See if that makes sense. Okay, that's a simple one. Let's do the next one. How about if I had they asked us to factor 3x squared plus 6x. What is my GCF of those two terms?
2x.
Not 2, right? Because I can't take a 2 out of here, but I can take a 3 out of both. And how many x's? 1. So my GCF is 3x. Okay, now I'm going to pull it out. Or divide. If I take a 3x out of 3x squared, what do I have left?
X.
If I take a 3x out of 6x, what do I have left?
2.
2. Good. Now I'm going to check myself. 3x squared plus 6x. Good. Let's say I didn't come up with the right GCF to start with, and instead I just said, I'm going to pull an x out. Let's see what happens. If I just pulled an x out of here, I would have 3x plus 6 left, right? I'm trying to show you it's not going to be an end-all if you don't find the GCF right away. You can whittle it down to the right answer. Say I didn't say 3x, I just said x. You always want to look in here and say, is this completely factored? Then you'd say, well, I can take another 3 out. So you pull a 3 out, then get your x plus 2. So sometimes it will take more than one step if you don't guess the right GCF. All right, let's try factoring 2x minus, 24x minus 18. What do you think my GCF is here?
6.
It's just 6. Good. 6 is the largest factor I can take out of both terms. If I pull a 6 out of 24x, I have 4x left. Here's a minus sign. Now, it's important with your signs, you just keep them the same. And that would be 3. Now check myself. 24x minus 18. Is everybody getting this?
I think what's confusing me a bit is you say when I take a 6 out of it, so I'm assuming you subtract 6 from 24.
Okay, I need to change my language. When I say I'm pulling a 6 out, what I'm really doing is dividing.
Okay.
I'm saying 24x divided by 6 gives me 4x.
Okay.
Because remember, I'm going to multiply it back to check myself. So the opposite of division is multiplication.
So I
You divide
divide the greatest
common factor. Okay. All right, let's say Ryan Dyer. What's the GCF of these two terms?
4w squared.
Good. 4w squared. So now I'm pulling out or taking out a 4w squared. What I mean by that is I'm saying 8w squared divided by 4w squared leaves me 2. 12w6 divided by 4w squared leaves me 3w4. Always check. Multiply it back. 8w squared, 12w6. Look inside. Can I take anything else out? No. That's as good as it gets.
And for that you go by what you did last chapter, which is 6 minus 2 would give us the 4.
Exactly.
Okay.
Yes. Yep. Okay, how about Michelle? What's the GCF of these 3 terms? Good, it'll be 4x. 2x would be a factor, but it would be the greatest common factor. So if you pulled out a 2x, you'd still get something inside the parentheses, and then you realize I can take more out. I can divide another 2 out. And if you're having trouble finding the GCF, there's going to be several problems to help you practice that. Sometimes that's the hardest part of this, is just figuring out what the GCF is. Okay, if I say 8x5 divided by 4x, I get 2x to the 4th. 12x squared divided by 4x leaves me 3x minus sign. 44x divided by 4x is just 11. Multiply it back to make sure you've done it right. Okay, how about Melissa? GCF. 6, good. Any P's? No P's, because this guy doesn't have a P to share. All they can give me is a 6. So if I take a 6 out of each term, I'm left with 10P squared minus 2P minus 3. Multiply back, make sure you got it. Next problem. What about Elizabeth? Not a 3 though, why? Just x squared, because he doesn't have any numbers to share with you. So x squared is all they can get. Good? Good. This is where you guys messed up on the test. X squared divided by x squared is a 1, so you still have to put that 1 there. Good. And then 9 what? Not x. Just y, because the x squareds will come out. Right? Very good. How's everybody doing with this? That 1 was the tricky part of that problem. Don't forget to put it just because they cancel out. What's the GCF of this one, everybody? Good. 6x plus 5. Sometimes the GCF is a binomial. I can take a 6x plus 5 out of both terms, and what do I have left? X plus 9. Cool. That's going to be very important. I'm not very So what's the GCF of that? Good. It's the binomial. 5y minus 2. What do I have left when I pull that out? Good. Minus 5. Excellent. One more like that, just to drive it home. Everybody, what do I pull out? X minus 3 is the GCF. What do I have left? 3x minus 2.
Do you need to have the GCF first?
Yes. Well,
It doesn't
no.
matter, right?
Math-wise, it doesn't matter which order. When I say you should put it first, is to show that you're taking that GCF out. But no, it doesn't matter if it's first. Okay, that is 5.1. And now we're going to go to 5.2, factoring by grouping. Factoring by grouping is basically what we've just done here. Okay. So the first step to factoring anything is always look for the GCF. That's what you got to remember. Pull out the GCF first step. Okay, 5.2, we're going to talk about factoring by grouping. if you have 4 or more terms, you can possibly factor by removing common terms. So factoring by grouping usually works for 4 or more terms. Here's an example. Okay, what variables in these 4 terms do you see are in common? Not common with everything, but are repetitive. C and D are M and N, right?
Yeah.
I have 2 C's and I have 2 D's. I have 2 M's and I have 2 N's. So if I were to take a C out of these first 2 terms, I would have M plus N left. If I were to take a D out of the last 2 terms, I'd have an M plus N left. Now, does that look like something we just did?
Yes.
The GCF is M plus N. And I have left C plus D. So you're factoring by grouping. You're taking things that are the same. The C's are the same, the D's are the same, the M's are the same, the N's are the same. Okay, so you pull out 2 terms at a time. The first 2 terms take out a GCF. The second 2 terms take out a GCF. Then you can take out the binomial GCF. So it's what we just did, but in 2 steps. We'll do some more with numbers, and hopefully this will make more sense to you. That's generic. Okay, instead of writing all this down because it's in the book, I'm just going to read it to you. Factoring a 4-term polynomial using grouping. That's what this is. First, you determine whether there are factors common to all 4 terms. If so, factor it out. Then, if necessary, arrange your 4 terms so that the first 2 terms have a common factor and the second 2 terms have a common factor. Then use the distributive property to group into 2 terms and factor out the GCF. So, all that wording, what it means, we're going to do in a problem. Okay, what it said, the first step, determine whether there are common factors to all 4 terms. In all factoring, the first thing you want to do is say, is there something I can take out, a GCF with all 4 terms? Does this have any greatest common factor? No. I can't take an X out of all of them, I can't take a 2 out of all of them. It has no GCF. So because it's 4 or more terms, I'm going to try to factor by grouping. So I'm going to group the first 2 and the last 2. If I take the first 2, what is their GCF?
X.
Just X. And I have left X plus 2, right? Then I'm going to look at the second 2 terms. What is that GCF? 6. And I have left X plus 2. Now I can take out a GCF of X plus 2, and I have left X plus 6. Okay? So factoring by grouping basically means taking 2 terms at a time, finding their GCF, and then hopefully there will be a common GCF to all of it. Then it's not factorable. Okay, right here, and you did one for me a minute ago, Zoe. Remember when we just had this and I said, what's the GCF? And it was X plus 2. So what you have left, if you take an X plus 2 out of both of these terms, you have an X and a 6 left. Okay? Let's look at the next one. Does this whole thing have a GCF? No. So because it's 4 terms, I'm gonna do them 2 at a time. What's the GCF of the first 2 terms? 3x. If I take 3x out of each term, I have 3x plus 2 left. Does everybody see that? Okay, I said 3x was the greatest common factor. And so I'm doing 9x squared divided by 3x, 6x divided by 2x. Okay? How about the next 2 terms? What's the GCF? Anybody? 5. So if I take a 5 out, I have 3x plus 2. Now these match, so they're my GCF. And what do I have left? Plus 5. Good. That is factoring my grouping. All right. How can I check myself on these? You what? Yeah, multiplied out. What was the term we used for FOIL? When they're 2 binomials, you FOIL it back out and see if you get what you started with. So that's a way to check on your test. 30x squared plus 18x plus 35x plus 21. How about Keeley? What are my GCF on my first 2 terms?
That would be 6x.
6x. If I divide 6x by both terms, I have left a 5x plus 3. Okay, Shannon, what is my GCF of my second 2 terms?
7.
Was 7. And I have 5x plus 3 left. It's really nice when it works out that way, because now I can take 5x plus 3 as my GCF, and I have 6x plus 7 left. So if you were to get to this point, you tried to factor by grouping, and this ended up being like 3x plus 4 or 5x plus 4, then you're done. You can't do anything else. That would be factoring. So it's only when it works out nice that you can take something else out. Yes.
Would you then separate all the terms then? Like would you do 5x plus 3, 6x plus 7, and then 5x plus 4? Or would the problem be complete?
It'd just be complete at that point. That would be as far as you could go. Unless you redistributed, then you end up back here. About Renee. First 2 terms. Good. What do I have left? Good. Now this one looks a little different. It's already x plus 7. There's not a GCF. But to factor by grouping, here's what we're going to do. We're going to say I can take a 1 out, right? Of each. So I want this x plus 7 to match this, so I can take them out. So by saying it's 1 times x plus 7, it allows me to pull out the x plus 7, and I just have x plus 1 left. Okay, so when the last 2 terms already match what you have pulled out, you're going to multiply it by 1. So that when you break these up into 2 binomials, you have x plus 7 and x plus 1. Melissa.
Can you switch to them by terms? So instead of the 7x and the x in the middle, can you just switch them? So that you have something in common?
Oh, these 2?
Yes.
Sure, you sure could. And that's another part of factoring by grouping. You can rearrange these to work for your benefit. So what she's asking is if I rewrote that 4 terms in a different way. If I moved the x to be here and switched it with the 7x here. Let's see if it still works. These 2 terms, I will take out an x, and I have x plus 1 left. These 2 terms, my GCF is 7, and I have x plus 1 left. So when I pull out the x plus 1 as my GCF, I have x plus 7 left. Looks just like this. Works the same way. So yes, because of the what property can I use around? Remember that? The commutative property with addition. It doesn't matter what order they're in, as long as they're addition. So that's perfectly fine to do that. Because she could probably see immediately that she wants her sevens together. Okay? So either one of these ways will work. Very good point, Melissa. Thank you. All right.
Actually, on that last one,
Yes.
when you multiply it out, can you take out an x and just make it a monomial? Sorry. So it would be
At the very beginning, take an X out of it.
oh, I guess I'm just looking at the bottom. Okay. Sorry, never mind.
Oh,
Dumb
okay.
question.
Okay, good. All right, let's look at this one. We can leave it in this order, or we can change it. But it looks okay with how it is, because the first two terms, what would be my GCF?
3x.
4 and an X. If I take 4x out of each term, I have 3x minus what?
1.
1. 1 is still there. Look what happens. Kind of looks like what we want, but the wrong sign. So, if this is negative, what would happen if I said I'm taking a -1 out of each of these? That flips the sign, doesn't it? This is kind of hard to see sometimes. I knew that I wanted 3x minus 1. This looks awfully close. But I want it to be the opposite sign. So instead of negative 3x plus 1, I want it to be a positive 3x minus 1. So how you can change those signs is to take a -1 out of both, and it flips their signs. Okay, so now the GCF is 3x minus 1, and what do I have left? 4x minus 1. Okay.
I like to do that, because -1 times 3x, would that be -3x?
It would, and see right here, it is a negative 3x.
And how would that be with GCF of both of them? Like the bottom, you say it's 3x minus 1 instead? But that's not true, because it's supposed to be negative 3x.
We made it 3x minus 1 because we divided the -1 out of each of these terms. By making this -1 here, that means I'm dividing -1 through each term. When I divide it through each term, it changes their sign.
So at the top there, that's a -3x?
This is, right now, it's -3x plus 1. In order to change these signs, if I divide each by a -1, it changes their sign to match this. The 4x here, okay, you got it okay? You'll kind of get to where when you see these, if this matches this but has the opposite signs, you'll just know if I take a -1 out, it changes their signs.
Can you do that with any number that you take out?
Yeah.
You can already use it, change the sign.
You can use, if you divide out a negative, it will change the signs. And it makes more sense afterwards to go back and distribute it. This makes sense. That would be -3x and a +1. Okay. P squared plus 8p minus p minus 8. This looks like it has potential to be one of those again. So the first two terms, what is my GCF? A p. What do I have left? Good. Now I have a negative p and a negative 8. I want a positive p and a positive 8. So I am going to factor out a negative 1. When I factor out a negative 1, it's like dividing by negative 1. That makes that a positive p, makes that a positive 8. I take out p plus 8 because it's common, and I have p minus 1 left. This is going to be one like Melissa was asking, actually. So I'm going to let Melissa start. What do I take out of the first two terms? 5x. And then what do I have left? Good. Okay. Now, my next two terms. What is the GCF? 2, which is correct, but let's talk about the sign. If I take out a 2, I'm going to have an x plus 3. I want it to be x minus 3. So I'm going to take out negative 2. Because then, if I take out a negative 2, I'm going to have a positive x and a negative 3. So the sign right here determines what these signs are going to be. And if you didn't see that right away, that's okay. Watch. If you just did it like we've been doing, and you say, plus 2 is my GCF, and then I have a negative x plus 3 left. And then you'd say, huh, that doesn't really match. How can I make it match? By taking a negative 1 out of both of these. So then I would say negative 1, making that positive and that negative. Then the x minus 3 is the GCF of both terms, and you have 5x minus 2.
In your answer, does the GCF always come first?
Doesn't matter. If you wrote it the other way, it would still be technically correct. Just in an effort to think about what we're doing, we're taking out a GCF, I always write it first.
Okay.
But it would not be wrong. Okay. I have hint page 291. I need to see what that is. Hint page 291.
It's just the negative.
Oh.
The third term is positive.
Yeah, it's at the bottom, the helpful hint, and it's talking about turning a positive into a negative. What were you just doing? Okay, so you might want to star that or make a note to go back and read it. Okay? 291. 291, the helpful hint is at the bottom. Okay, let's look at one that's factoring by grouping, but it has more than one variable in it. Okay, the first step, again, to any factoring problem is to first see if there's a GCF I can take out of everything. And there's not, right? So if you can't take out a GCF of everything, then you start factoring by grouping. T comes out of the first two terms, and I have r plus 3 left. What's the GCF of these two terms?
Negative 5.
5, but it's a negative 5. Because I want this to be positive. I'm going to take a negative 5 out, which gives me a positive r and a positive 3. Then I'm going to take the r plus 3 out as my GCF, and I have t minus 5 left. Very good. Okay. A GCF. Just start with. And they have to have 4 or more terms for this to work. Okay, I'm going to write 3 problems on the board for you guys to try on your own. First one. Second one. Third one over there. first one. How about David? How did you do this one? What do you have left here? And you take a 3x out of 6x squared? Because remember you're dividing 2x.
Yeah, 2x plus. I do 1y.
Yeah, that's right. It's y, but you can write 1y. Very good. And what did you take out of the second two terms?
4y.
Can you take a 4 out of here though? Okay, so what can you pick out of? 2 and a y. Good. So you have 2x left. Then what is the GCF? 2x plus y. Good. 3x plus 2y. Very good. Anybody have questions on that problem? Okay, let's try the next one. How about Sarah? Okay. Ready? Good. Okay, good. You're on the right track, but what's different about these two? So what do I have to change that?
No,
What?
just look up top, it's a negative.
Oh, it's already negative. Okay, so you did it the right way.
Yeah, you were right.
Okay, good. So you pulled out a 2r minus 3s, and what do you have left? Yeah, that's right. Good. Excellent. So you have to pay attention to this negative up here. When you take out the 3s, or you're dividing 3s, you have a negative 3s left. And you did have to match this one, so I did this one. Good. Any questions? Okay, the last one over here, how about Scott?
I pulled the x plus 5 out of it. So 6x out of it. The x plus 5.
Good.
And then I did negative 18.
Good. If you didn't see that 18 was a factor of 90 right away, you may have only pulled a 9 out. And let me just go off to the side here for a second to see what would happen. If I had only taken a 9 out, I would have had 2x minus 10 left. And then you would see, oh, I can take another 2 out of 2 and 10, bless you, making that 18. So it's okay if you don't find the GCF right away, as long as you're continually looking in here to say, did I get that factored out as much as possible?
That would make that a constant.
I'm sorry?
That would make that a constant.
Oh, yes. Okay, so sorry, Scott. Go ahead from here.
And then I grouped the x plus 5 and 6x minus 18.
Okay, now on this one, I think this is the first one we've come across that this has happened. When you get to this point, typically we're done, right? But take a look at these binomials. Are they completely factored? Why not?
Was it 16 or
Because this, I still can take a GCF out. So you always need to look at your final factor and say, is there anything else I can take out of those parentheses? And in this one, I can pull another 6. So this is actually x plus 5. I'm going to take out a 6, make it x minus 3. To rewrite this nicely, you might want to rewrite it like this. It means the same thing, it's just written with the coefficient in the front. But it's the first one we've done so far that that's happened. We get to the final point of factoring 2 binomials, but we recognize this is not factored all the way. Okay? So just please watch for that when you do the final factoring answer, that there's nothing else we can take out. All right, that was 5-2. On to 5-3, factoring trinomials. Woo, woo, woo. Well, these are going to be trinomials that start with 1 as a coefficient, so they're not too bad. Factoring trinomials of the form ax squared plus bx plus c, where a is going to be equal to 1, meaning that the lead coefficient in these problems are going to be 1. Now, does anybody know what a trinomial of this form is called? Okay, it's called a quadratic. It's called a quadratic equation. You just might see it referred to that. Quadratic equation just means you start with degree 2. The trinomial starting with degree 2. Alright, so let's look at our first one. In this quadratic, or trinomial, what is A in this form? A is 1. What is B? 7. What is C? 12. Okay? So I'm showing you in this form, sorry, A, B, and C, what it is in a real equation. Okay? So when I refer to A, B, C, that's what I'm talking about, is those coefficients. When we are factoring a quadratic, what we're really doing is reversing it back to 2 binomials. So remember when we FOILed this? First, outside, inside, last. When we FOILed that out, we ended up with x squared plus 7x plus 12. So all we're doing is going backwards. Quadratics are going back to the binomials. So it's like FOILing backwards. Okay. If we are trying to go back to 2 binomials, what we're trying to find is these missing numbers, right? So I have these 2 numbers, 3 and 4, that were my binomials before we went to this trinomial. So if I have a trinomial and I'm trying to get back to the binomials, I'm looking for these 2 numbers. What this always will be is these numbers will add to BB, and they will multiply to be A times C. Okay? And this holds true here. These 2 numbers, 3 plus 4, added to BB. They multiplied to be A times C. 1 times 12 is 12. Okay? So these 2 numbers add to BB, multiply to be A times C. This will be more clear when we do another problem. Any questions though right now? I've presented it.
Do they call that anything?
They call it anything.
Yeah.
No, it's just, I don't know a name for it. It's just factoring trinomials.
I was in a dream world. Can you just explain how you got x plus 3 and x plus 4 from it? But just,
This.
yeah, that was just,
What I was trying to do
Oh,
is
yeah,
show
that-
that,
okay.
that this quadratic factor goes back to these 2 binomials.
oh, okay.
And I'm explaining that what we're doing is the reverse of what we learned last time. Last time we FOILed this to get this. Now we have this and we're trying to go back.
Oh, so you haven't explained how we got back to it yet.
Well, other than I said,
Okay.
these 2 numbers are always going to add to be the B, and they're gonna multiply to be A and C. Okay, that is the trick, if you will, or how we solve these. Okay, so let's look at our first problem. What is A in this problem? What is B in this problem?
12.
What is C? 20. Okay, so when you see a trinomial, this is what you're going to write over the side. You're going to say, what plus what equals B? What times what equals A times C? So this is B, this is A times C. Okay? These two little lines over here to the side are going to be your key. And they have to be the same numbers. Two numbers that will work to be add to 12, multiply to be 20. And you're right, it's 10 and 2. So 10 and 2 work for both scenarios. They add to be 12, but they multiply to be 20. Does that make sense? There's other things that would add to be 12, right? But it wouldn't work to multiply to be 20. So you have to find two numbers that work for both scenarios. Yes. Okay? Then once you've found that, you write your two binomials. X plus X plus. Boom, boom. The numbers we just found are what you're going to plug in. Voila.
2.
He is my fact checker today. No, you're good. Obviously,
Just
it's
for
a
the
mistake.
answer.
Okay, so the two numbers we just found go in there. We are done. We factored this trinomial. How do I check it? I FOIL it. X squared plus 2x plus 10x plus 20. Combine like terms. And I have what I started with. So it is truly the factorization of that quadratic. Is my answer. Makes sense to everybody so far? Good. Okay. Look at another. Okay, what am I going to write over here to the side? Blank plus blank have to be 7. Blank times blank have to be 12. I just did it?
Yeah, we did a 7.
Oh. Sorry. So x plus 4, x plus 3. Very good. We'll do it again.
In this chapter, we're going to get into where it's like 7xy plus y12, or 12y or something.
No, that's next
Okay.
section. Okay, let me do one more for you before I go into the positive negatives. Let's do x squared minus 13. X squared minus 13x plus 12. This is our new problem. So what plus what equals negative 13? This sign goes with it. What times what equals 12? So what would multiply to be negative 13 but add to give you a positive 12?
2 negatives.
Right? Okay.
12 and 1.
12 and 1, but which one is negative?
Both have to be negative.
Both have to be negative. If both are negative, does it work for this? Yes. Okay. So here's where your signs are important. Negative 12 and negative 1 become a negative 13. 2 negatives equal a positive 12. So now when you write it, it's x minus 12 and x minus 12. And check that by 4. Alright, here is a little hint as to when they're going to be positive or negative signs. Okay, if, like the one I just showed you, there's a negative in front of the b, they're going to have the same signs, both negative. And that held true, right? Same signs, but they were both negative. If you have a negative in front of the b, but you also have a negative in front of the c, they will have different signs, opposite signs. So one will be positive, one will be negative. If you have a positive in front of the b, but a negative in front of the c, they will also have different signs. And lastly, if you have a positive in front of the b and a positive in front of the c, they will have the same signs, both positive. So really, if you look at this, what the key is, if the sign in front of the c is positive, they're going to have the same signs. And the same signs are going to be whatever's in front of b. If there's a negative in front of the c, they're going to have different signs. So if you can just remember that, positive in front of the c, same signs, negative in front of the c, different signs. Okay, just looking at these two first, the only thing that's different is the sign in front of B. So based on what I just told you over there, how should this one turn out? They're both going to be positive. So when you write your binomial, you know they're both going to be positive. What will this be?
Both negative.
They're both going to be negative. Very good. So because they're the same other than that, it's still going to hold true. Something plus something has to be 11, or negative 11 in this problem. Something times something has to be 18. So what two numbers will it be here? 9 and 2? And it'll be 9 and 2 up here as well. The only difference is the signs. Make sense? Okay. Okay, how about these two scenarios? In both of them, they're going to be different signs. We just don't know which one will be positive and which one will be negative, because obviously they're going to turn out different. So let's try this. We know they're going to be opposite signs, but let's do each problem. In this one, they have to add to be negative 7, and they have to multiply to be negative 18.
So C always comes to the B.
Yeah, because the negative is in front of the C, we know it's going to be opposite signs in our answer. But because this one's negative and this one's positive, it's going to change which number is which. So for example, in this one, what two numbers work for this? Negative 9 and a positive 2. Negative 9, positive 2, make sure that works. It works for both scenarios. So in this case, the positive is the 2, the negative is the 9. But let's look at the same problem down here. The only change is the b is positive. So now we have to add to be a positive 7 and multiply to be a negative 18. This time, the 9 is positive and the 2 is negative. You see that? Okay, So the signs make a big difference of, they were both 9 and 2, but in one the 9 was negative, one the 9 was positive. The key is making sure this works. You don't memorize the signs so much if that confuses you, just make sure this works and you'll be okay. Alright? We're doing good. We're almost there. 2 more sheets. Okay. You guys want to try them on your own?
Sure.
Try that one. Try that one. And this one. This is where knowing your multiplication facts are critical. So you're not going to find factors if you don't know the multiplication facts. I'm going to add more for those of you who just need more. Easy people.
We've never done one where D is an X. We just make it equal.
Where the what?
The B, A, B.
Yeah, what's
just make it
the
equal.
coefficient of B there?
1?
1. That's all. Yeah, it's just 1.
I didn't know.
That's okay. Yeah. go ahead and start one over. Okay, this first one.
Okay. So the common factor is 9, 8, and the x's and the x plus 1
Good. Okay, I'm gonna go through it one step at a time so everybody sees what you did. So something plus something has to be 1, right? And something times something has to be negative 72. So that's how you got the 9 and the 11. Is it positive 9 and positive 8? Negative 8 and positive 9. Good. That will make it work for both. Also, we see that the negative in front of the C means that we're going to have opposite signs. So we know there's going to be one positive and one negative. So I have x plus 9 and x minus 8. And I can check myself up for 1 and a half. Okay, good. How about Michelle over here? What do they have to add to be? They have to add to be negative 1. And they have to multiply to be the C, negative 72. Okay? So they're adding to be the B, which is negative 1, and they're multiplying to be C, which is negative 72. So this looks similar. We know that because this is negative, they're going to have opposite signs again. But here we're going to have a negative 9 and a positive 8. Is that the only way I'm going to add to be negative 1? So it's a similar problem, just different signs. So this is x minus 9 and this is x plus 8. Make sense? Yeah. All right, the next problem.
We have to add the negative 11 and multiply the positive 30.
Good.
Negative 5 and
Good. Negative 5 and negative 6. Because it's positive in front of the C, I knew they were going to be the same signs. This tells me they're both going to be negative. So I had x minus 5 and x minus 6. Very good. And so far, they're all factoring out to where they're completely factored and we don't have to take anything else out. Okay, let's look at this problem. Here they have to add to be 4, and they have to multiply to be negative 32. The negative sign tells me they're going to be opposite signs. So one will be positive, one will be negative. What two numbers work? 8 and negative 4. Yep, because they add to be 4 and then multiply to be negative 32. So here I have a t plus 8 and a t minus 4. Very good. Foil to check yourself. Okay, next one. Here they have to add to be negative 14 and they have to multiply to be 49. This positive sign tells me that they're both going to be the same sign, but they're both going to be negative. So the only thing that works is negative 7 and negative 7, right? So it is x minus 7, but what's another way to write that? Good. X minus 7 squared. There you go.
Is that how you want it on the test to do it, like x minus 7 squared?
And if you'll notice, this was that rule, that special rule for binomials, if they're the same, that you square the first one, you take twice these two, and you square the last. That was one of those special rules. Okay, last one. These have to add to be negative 11, and they have to multiply to be negative 16. The negative tells me they're going to have opposite signs. What works?
4 and negative 15.
15 and 4, is that what I heard?
Negative 15.
Negative 15 and a positive 4. Good. Sometimes the hardest part is trying to think of the two things that would work, right? What's one way if you're stuck? You just find the factors of 60. 1 and 60, 2 and 30, 4 and 15, oh, I forgot 3, 3 and 20, and so on. You do all the factors, and then you look at them, and you say, which ones could I add to give me 11 if I change the signs? Okay, that's one way to figure that out. I don't know why you guys are packing up, but it's been a minute. Okay. Because we're not quite done. You did it, 10 till. Is the clock wrong? Is it not 20 till? No. Okay, well let me see what I can do in 5 minutes then. This is important to know what a prime polynomial is. A prime polynomial, what do you think it means? What's a prime number? One and itself. You can't factor it. So for example, if we went to try to factor this problem, we would say what adds to be 3 and multiplies to be 8. Can you think of anything? No. If you went through the scenario of 8, all the different factors, you'd see that nothing adds or subtracts to give me 3. So this is called prime, and it's not factorable. Okay? And you won't know that till you try to factor it. You can't come up with any factors. Then that's going to be prime.
And that's how we have to show our work.
Yes, then you'd have to show your work that you tried. Okay, this one. Is there anything that adds to give me 10 and multiplies to give me 20? Well, 20 factors are 1 and 20, 2 and 10, 4 and 5, or any combination of that going to give me 10? No, so this one is also prime.
You just write prime or do you write non-factorable?
Either one. Prime or non-factorable, I will accept. Okay. The last thing I want to show you today before you leave, just so you'll know how to do your homework, is sometimes there's going to be a form where there's 2 variables. And if we have to rush through this, I'll cover it at the start of next time, but I at least want you to see it. Sometimes you'll see a form where they stick in an extra y here. It's still a, b, x, c, but they put an extra y at the end. So when you go to factor it, you're still going to have your binomial with an x. But whatever number you find here, there's going to be a y stuck at the end. Okay? So when you go to find it, just know if there's a y squared at the end, there's going to be y stuck on the end of these numbers. So to solve it, you're still going to look for what plus what equals b, and what times what equals a times c. Still what you're doing. But this extra variable is going to be stuck at the end. So here's one example, and then I'll let you go. Okay, so this has the extra y, so when we solve, whatever number we find is going to have a y at the end. And because this is positive, we know they're going to be the same signs, and they're both going to be positive, so I can go ahead and write that in. So I'm looking for 2 things that add to be 4, multiplied to be 4. 2. So this is x plus 2y or x plus 2y squared. Very good. Make sense? Yeah. Okay, and last, what is the first step of any factoring problem?
Find the greatest common
factor. So even when you have a trinomial like this, a quadratic, before I start factoring this, what would I need to do?
Take out the 3.
I can take a 3 out, and then look what happens to my problem. Then I work on factoring this like we talked about today. So if you see something starting with a coefficient, see if there's a GCF to take out and then factor from it. Okay? Start your homework, please. There will be a quiz Tuesday. Have a good weekend.